good morning to everyone. Well, good morning here. I'm going to present my dissertation. It is OpenBIM models, quantity takeoff, and cost estimating, process automation for buildings. I'm sorry. Okay, so the main objective of this dissertation was to generate a quantity takeoff and a cost estimation process by using a word-based structure. This process should also implement an open-based approach by using OpenBIM into the project. This is basically to promote interoperability to the whole process and generate modeling rules for architectural discipline in a construction phase. So in order to understand the workflow that I'm going to present, we need to understand the main concepts. The first one is the work-based structure, or the WBS. This is a deliverable-oriented hierarchical decomposition of a project, and there are two main types. The first one is a deliverable-based WBS, which focus on the end results of the project. And then you have a phase-based WBS, which focus mainly on the stages of the project. So integrating WBS into a quantity takeoff process is important because it allows us to divide the project into smaller and more manageable elements, just as shown here on the graph. And for the scope of this presentation, we're going to use the General de Precios by SIPE as the main WBS. So another important concept is OpenBIM. So as you may know, OpenBIM is a collaborative process that aims that all the information is accessible to all stakeholders in every stage of the life cycle of the building by using neutral software providers. So if we talk about OpenBIM, we need to talk about Building Smart, which is the international organization that develops the standards to promote OpenBIM. So as you can see on the screen, there are several standards, but we're going to mainly focus on the last two, which is IDS and IFC. So IFC is important to this whole process because throughout its schema, just as shown here on the screen, we could extract the quantities of each element and its materiality. Finally, we have a quantity takeoff and cost estimation. The quantity takeoff is a process that measures and quantifies all the elements that are in the project. And the cost estimation is what basically gives them the cost. So at the beginning, there was a 2D manual interpretation process, but throughout a BIM-based approach, this process became a little bit more automatized. Still, it faces some current limitations, just as shown on the screen. And the presented methodology generates some strategies in order to approach them. So we can talk a little bit about the proposed methodology. This one is divided into 5 main steps that are going to be explained later. But some generalities of this methodology is that first, it aims for data consistency by defining the WBS structure as its first step. Then the user can use whatever authorizing software he or she needs, because the main file that we're going to use, it's the IFC, which its quality and reliability is going to be tested throughout several filters during the model verification process. So whenever everything is ready, you can proceed to cost assigned, to assign the cost to every element on the project to finally generate the cost estimation report. So for the scope of this presentation, I'm going to be showing the proposed methodology alongside the case of study of my dissertation, which was the Lagoa house provided by Martha Campos. So if we talk a little bit about the WBS, this is a really important step because it defines all the elements that are going to be in the project and how they're going to be structured. So in order to have a better management and control over this, it is necessary to generate a table similar to the one seen on the screen with its proper identifier description and the unit of measurement according to the WBS. Then we have the modeling rules, which is the first step of the 3D model generation. They're quite broad, so I'm not going to talk too much about them. The first one is to follow the WBS because it basically gives the whole structure to the project. Then define a proper level of information you need to define basically the quantity, quality, and granularity of information per element. Minimize geometrical information. This will make more sense on the next slide. Follow real-world precision. I mean, if we're talking about quantity takeoff, the more accurate is the model, the more accurate will be the cost estimation. Avoid excessive modeling components. This aims basically
Hello, Andrea. Look like we lost Andrea. Let's just wait a little bit until maybe she will come back. We'll wait 1 minute.
so to have a sorry. So
sorry, Andrea, for interrupting, but we lost the connection here for 1 minute. So if you can just go back 1 slide and continue from there. Yeah,
here.
In the middle of it, we were already by the end. You can start from the end almost.
Okay, from avoid excessive modeling components, it's okay?
Yeah.
So avoid excessive modeling components is basically to extract the quantities of an element using an element that it's already into the 3D. So basically, it's not to have all the elements already in the 3D model, but just like extracting other quantities throughout the elements that are needed in the project. Like, for example, we can avoid model skirting or the flashing in C and use the proper IFC schema. So the second step of the methodology is the 3D model. So this is mainly divided into 4 main steps. The first one is to define the elements that compose the project. So in order to approach this step, we decided to use 10 architectural instances. I'm not going to show them here, but you can find them in my dissertation. And throughout these 10 architectural instances, we decided some modeling guidelines in order to establish how to approach the modeling process per element and what are the properties needed from the WBS. The second step is to define the proper level of information need. This is basically to define the geometrical information and alphanumerical information of the elements in order to have an accurate quantity takeoff. Okay, then we have the 3D model generation itself. So there are 2 main aspects in this step. The first one is to that the modeling process should be done in a structured way. This is basically to help prevent any missing elements from the project, and it's easier to consider all the modeling rules per element. So as an example, in the Lagoa house, what I did was to first generate all the exterior walls, then interior walls, and so on, until I have the whole geometry of the project. So the next one is to aim for accuracy. As you can see on the image on the right, this can be a little bit problematic, especially when dealing with compound elements. So in order to solve this problem, I use the parts tool from Revit, which allowed me to individually modify the dimensions of each layer of the compound element. So instead of having a general quantity takeoff, you have a more specific one. So in some information that should be added into the previous step, it's first the naming convention that in this case, I've used the NBS object standard. Then the materials with its proper name and RGB color whenever it's applicable, WBS codes, and its IFC schema. So at the end, each of the layers or individual elements should have something similar to the description shown on the image. And finally, we have the IFC export. So in order to have a proper IFC file, we recommend to use the following configuration, which is the first one, the IFC version should be the IFC for reference view. Then the property set that should be included, it's the IFC common property set. The base quantities, a user-defined property set. This is basically to map all the elements that doesn't belong to the IFC schema or that are not exported correctly, and use the export parts as building elements. Then we have the third step, which is the verification process. This is mainly divided into two. First, we have the geometrical verification, which consists on a clash detection study and a manual verification of the modeling rules applied to each element correctly. And then we have the alphanumerical verification or information verification that is done throughout the IDS, which is another building smart standard, which aims to make sure that all the properties per element are correctly exported into the IFC. Then we have the cost design process, which is the fourth step of the methodology. This can be done throughout the generation of a cost database, which for me was, I was using the OpenBIM quantity software by site. And what I did was to integrate all the information from the general order pressures per element into the cost database of the software. Then I did the set of rules of measurement, which is basically linking the WBS code from the cost database into the WBS code used in the IFC. And then generate a bill of quantities, which is generate a cost estimated based on the single cost applied to the extracted quantities of the project. The final step of the methodology is to generate a cost estimation report. So as you can see here on the screen, there is extract parts of the Lagoa House cost estimation report. It first should be divided throughout the instances that are in the project. For example, here we have the floors. And then it should reflect the total cost of the project. So the conclusion of future developments, I'm going to focus mainly on the main achievement of this dissertation towards the generation of a cost estimation report of a project, basing the whole workflow in the WBS from site, which is the general process. This whole workflow was done throughout using IFC as its main source of information throughout an automated process, thanks to the coding system also extracted from the general process. And importantly, it's the generation of modeling rules for an architectural discipline in a construction phase. So this basically opens a future development to introduce basically this process into other disciplines or to other stages of the project, and also integrate new or updated standards to the process. So thank you for your attention.